The Runcam 2 offers a wide input voltage range of 5 to 17 volts, making it suitable for USB power, 2, 3, and 4S LiPos, as well as car applications. It also offers an advertised less than 600 milliamp current draw, but as usual that's not particularly helpful, as the difference between 600 milliamps at 5 volts and 600 at 17 volts is about 3 times as much power. So I'm going to find out exactly how much power the Runcam 2 uses under several different conditions at a couple different fixed voltages as well. So a couple things I'll be measuring. Already got one reading in, the minimum battery voltage. I turned on the camera, waited for the battery to run down, the camera turned off automatically, and the resting battery voltage is 3.53 volts. I'm not sure what the exact under load battery voltage will be, but at this voltage the camera will not turn itself back on. I'll charge it up and get the maximum voltage as well once I'm done with the testing. I'm expecting it to be 4.35 volts, but we'll confirm that later. I'll be measuring the power and current at 5, 8, 12, and 15 volts, running just video out, and 1080p, and just recharging the battery. And I might do in all three combination together as well if I have time. So I have already done most of these tests, but ran into issues because I used too small of a servo connector wire, which caused a lot of voltage drop and all kinds of weird readings. So this time the setup will be hopefully as good as it can get under my equipment conditions. We've got an adjustable voltage regulator here. We have thick 4mm banana jacks for the current sensing, and then we have voltage sensing after the current sensing, so the voltage on this multimeter should be as close to the camera voltage that I can get, as the sensing's right there. So there's only a single servo connector between the voltage on the multimeter and the camera itself. Alright, so one thing I will be doing with these readings is I will be making sure that the actual camera output voltage, or going into the camera, is as close to the reading values here as possible. So this was 5 volts before I turned the camera on, but the load of the camera dragged down a bit. To keep all the readings accurate, I'm going to manually boost up the voltage so it reads 5 volts, even as the power level required by the camera changes throughout the tests. So that might not be exactly representative of what you're going to see in your tests, where you have a fixed input voltage regardless of how much power the camera's drawing, but it should keep all these tests here accurate. So let's see what we can do here with the output voltage. So there we go. That's basically how I'm going to do all these tests. I'll run it like this, 360 milliamps, start the recording, and I don't actually need to increase the voltage any, that's close enough. 518, I'll go with the highest reading reasonable, and then increase the voltage, record everything, and we'll see what we get. Alright, here's our initial readings, and pretty much no surprises. Even when I did these tests initially, this wasn't too surprising. Basically, the current drops proportionally as the voltage increases, and the wattage required does not change within the measurement error, as this multimeter is slightly off on voltage, so it's very likely that the required wattage power is identical at all voltages. The camera, of course, will have a switching regulator, meaning that it can convert the voltage and the current to the power required with very little losses. So yeah, you can see those are your readings with recording and just video out. Now I will pop the battery into the camera, and we'll start measuring some currents for charging. Alright, here's our battery charging power usage requirements, and the battery will actually charge faster than the current used and wattage used to discharge it at video and 1080p recording. So we're getting about 3.4 watts or so. You lose a little bit of power at 5 volts, and we're a little bit over the 600 milliamp advertised maximum current. Not that that really matters. So since this is going pretty quick, I guess I'll do an all three test as well. I'm running down the battery and the camera again so that we have a relatively fair starting point, and once that's done, I will measure the current used when the camera is doing its maximum amount of stuff. Now, it's worth noting that the camera is making a relatively not convincingly good sounding squealing noise right now, and that doesn't seem too good. Also, consuming quite a bit of power. So let's do this quickly before things get heating up. And I don't know if you've noticed, but I've turned this voltage adjustment knob the wrong way every time so far. Also, the squealing stopped at around like 5.5 volts. So I guess that's a good thing. Yep, getting a little warm. Considering it was relatively cooled off before I started that, it heats up pretty quick when you're doing a lot of stuff. So I guess I'll just calculate the wattages here. As you can see, they are a little bit higher. From my previous testing, and we'll see if this holds true, you're only getting about 1 watt of battery charging effective power when you're doing everything else too. But we'll run those numbers here and just confirm that. But it's looking like that. Doing all the things leaves you with about 1.2 watts of effective battery charging power if you subtract the wattage of full power minus the wattage of just 1080p plus video. You get these numbers. So that's a really good thing, as you don't want to really be spending too much additional power than you're already using charging the battery, as the camera gets pretty warm on its own just recording video. So too much additional power diverted into charging your battery in the same conditions just adds more heat. But you are losing out on quite a bit of charging speed. It's about close to 3 times slower. And I believe that the camera says somewhere in the instruction manual not to have the battery in place when you are doing FPV recording, basically, because it gets too hot. Now, I'm wondering if that's because it gets too hot for the battery just normally, or if the additional load of charging, in addition to all this other stuff, gets the camera too hot on its own. But regardless, I've not used the battery when I've run my camera, and it works great at 12 volts. So that's what I'm going to keep doing. Now, next thing we're going to find out is the maximum possible input current. With a little bit tweaking around the 5 volt range, I think we can get the current a little bit higher than that. And also the minimum voltage. Now, there's going to be a bit of interesting things going on here, as I already mentioned that the camera makes a slight squealing noise when it's under heavy load at low voltage, and it gets worse when you go below 5 volts. So I'm going to see if I can find out the minimum voltage where there is no audible noise coming from the camera. Also, I know that the squealing from this camera does not get recorded on that camera. So I have a video that I will include a clip of at the end of this video with a different voltage regulator similar to this one making a squealing noise, and I'll explain that a little bit. But let's see what we can get going here. Now, there is already squealing noises. Interesting current readings. It seems like the charger temporarily shuts off during the startup. Squealing. Oh, we're breaking 800. And we're ramping down. Okay. So that looked like, what, 815 or something? That's about as comfortable as I feel getting, as if camera's making noise, probably not that great for it. But that's just something to keep in mind. Now the battery's in place, so theoretically, you know, you don't have to worry as much about running out of power because it will just run on the internal battery if it needs to. Speaking of which, let's show, now as you saw, the current input drops off as the voltage decreases. And I'll just record this because you can basically see how much charging power you're getting as the voltage falls too low. So it seems to start dropping around 4.6 volts. And around 4 volts it just completely stops. Now, that voltage that it stops at may change as the battery itself charges up, because once the battery gets to, you know, its full 4.35, I'm assuming, maximum voltage, the minimum voltage required to charge it may increase. Maybe I'll test that, maybe not. Alright, now let's see what happens when we start getting voltages with no battery. Now I am kind of hoping this doesn't somehow damage the camera. Under voltage conditions would not be uncommon in a, you know, RC model whatever, so this shouldn't be destructive if it was designed well. I'm not hearing any squealing. And I'll check the video on that, but it looked to be a tad over 4 volts, which isn't too bad. That gives you some wiggle room for brownouts or whatever else if you're powering this with a 5 volt like BEC connection. And I'll do the same test again in a second with the 1080p video recording. The previous cutout looked to be right at 4.1 volts. Let's do this again. Now I guess I'm going to be expecting some squealing noises, and I hope nothing blows up here. But I guess we'll find out that as well. Still turning this knob the wrong way. Squealing starting. Getting worse. And a tad bit higher, but hopefully it didn't blow up. Now, let's see. I noticed something when I increased the voltage. the camera turns on for a second. It appears when voltage is applied to the camera, it does some kind of startup routine. Not exactly sure what it's actually doing, but it draws a bit of power when you first plug in it to power. And also when you increase the voltage from too low past some kind of like 4.2 volt threshold, it does the same thing with a small amount of squealing in the process. The last two things I want to find out are what is the minimum turn on voltage for the camera and what is the minimum power voltage that does not result in any audible squealing as far as I can hear when recording 1080p. So it looks like the actual voltage required is not much more than the minimum needed voltage. Nope, that's too low. It's drawing a bit of power here. Looks like it just did that initialization thing. So about 4.3 volts is what I'm going to call the absolute minimum voltage needed to turn on the camera. Now, I'm wondering, is there a voltage? I don't think so, but I wonder if there's a voltage that would cut the camera off when you click the record button, because it's barely at enough to run the FPV output. When you start recording, then it suddenly can't do it. But, I mean, I guess technically it is recording now, even if it's making very not good sounding noises. So, where do the not good sounding noises stop? Oops. Oh, you see this? I'm glad it did that. I've noticed that. I wonder if it'll do it again. No. Sometimes, under low voltage conditions, and I'm glad I caught that because this is what the first thing I ever tested it did, and I couldn't figure out what it was doing until I plugged the screen in. Sometimes, when the voltage isn't right or it's not happy, it'll say unauthorized across the startup splash screen and then turn off. It's kind of weird. And of course, I didn't see anywhere on Google mentioning unauthorized Runcam, so I don't really know what's going on with that. So I am hearing squealing noises. Very, very light squealing noises. Still audible. There's a different noise that's not as high-pitched. I don't know if it always does that. I never really put my ear directly up to it while recording, but the squealing did stop at that previous voltage. Now it sounds just about completely quiet. There's no high-pitched noises. There's a slight, like, I don't know, static noise. That might be just a continuous. Alright, now it's completely quiet. So it looks like really you need like 4.8 volts to not have some kind of weird squealing, and 5 volts to not have any kind of noise that I can tell at all. Which, if you're powering this directly from a LiPo battery or something, you should be good to go there as long as you have 2S or above. If you're powering it through a marginal USB or other 5 volt supply, you might be running into problems. I don't know if that noise that it's making is necessarily bad, but it doesn't sound good, and I don't know if it's picked up by the microphone on the camera, but if it is, it's also not good for your videos. So that would be my conclusion there. You probably need, I'll check the video again there, but it looked like 4.8 volts for no noise, what I'll call it. And then 5 volts, there was, I don't really know how to explain the noise it was having, but it didn't sound as problematic. The camera's been charging for almost 2 hours now, and the current charging has really fallen down into the trickle charge sort of range, the CV voltage stage, I'm assuming. And at some point the red light on the camera will turn off when the battery gets charged to some point, but for now I think this is sufficiently accurate of a reading to take a battery voltage measurement. So let's see what kind of voltage we're getting here. .346. So it's pretty reasonable to assume that 4.35 is the actual fully charged voltage of the battery on the camera. That's good trivia to know. Especially since if you find a random, like, not high voltage LiPo that fits in here, and then you put it in there and the camera fully charges it, that might not end, you know, like you want to. Now, the one thing I didn't test is if there is a difference between the current draw when a TV FPV screen is connected to the camera and when it's not. Now, I don't know if it actually detects whether or not something is connected to it, or if there's really even that much power being used by such a video output. So let's just see if anything changes plugging in the TV screen or not. So battery out, power good, current on, camera plugged in, power up. So 300 milliamps, and if we unplug the screen, absolutely no change. $450 or so, still no change. So there is no power saving benefit by not having something plugged in here. Alright, I think that concludes all my testing here. I will post a close-up video or picture of this which I have measured, and hopefully that will be useful to someone somewhere for how to power your Runcam 2 and what to expect under all the different conditions that you might come across. Thanks. So what is that strange noise that comes from the camera when the voltage is too low? Well, from my experience, which I will demonstrate here, it is when a buck converter has too low of an input voltage for its requested output voltage and load, causing the coil to squeal and the regulation to drop out. So, for example, if I change my input voltage here down, you can see the secondary regulator is now making all kinds of weird noises. Is that bad? I don't really know, but it doesn't sound good, and if you want your audio and your video to sound right, you definitely don't want that happening. So, be sure to provide enough voltage to your Runcam 2.